Moving to our first panel of the day. Ali, don't go too far. I think you're part of the panel. So the moderator today is going to be Ashik Antrim from Leicester, and Robert Chisholm, Jonathan Cooper, Carolyn J, Chris Richardson, and of course, Ali. Yeah, so go ahead. Podium. We'll make sure these mics are all working.
Yeah, so I'm Ashik Anjum, and I will be moderating this panel. So this is probably the most diverse kind of topic. And we have only 30 minutes, so we will try to have as many questions as possible. And I hope that we would have interesting discussions. Probably I would just like to start an open-ended question, and then we would open the forum for questions from the audience. So everyone was talking about, to some extent, energy and the performance. So, but probably in most of the HPC centers, we are seeing that energy requirements are going up and up every year. And some people are saying that AI would, to some extent, push the boundaries of data centers to an extent that there would be a kind of 100% increase in energy consumptions by 2030. So that is, to some extent, having an impact on the environment. And we says that, is it a responsible use of HPC centers? So what is your a kind of take on that? So what could be the best way forward where we could still get a good performance without having a lot of impact on environment, so that people could say that we are doing responsible HPC for AI? So over to you.
I think I'm the energy. Can you hear me? Yeah. So again, I'm the energy guy. Maybe that's why I should kind of start with that. Again, as you said, that everyone is talking about AI, everyone is talking about the HPC algorithms and everything, which are generating, again, massive energy. So the thing is, we need to come up with, I would say, responsible attitude through which, first, I think we need to focus on the working on improving the culture of like workflow categorization. It's a bit different thing, but if we talk about workflow categorization, okay, that means the task which you are running, if you can prioritize or categorize those tasks, because right now our attitude is that, okay, I have a small task. I want all sort of energy which I can get. I want all sort of performance computing power I can get, because I just want the result as quickly as possible. Sometimes it's not always the case. I mean, we don't want performance all the time. We can compromise the performance if we categorize our priorities, if we categorize those tasks into different levels, and then according to those levels, we can allocate the resources, because giving up all the resources to few things at the cost of energy is, I think it's not very responsible. I think it's time we need to change our attitude, because right now everything is AI, everything, and AI is based on HPC. So, and HPC is consuming energy. So we need to find the balance between the cost and performance. Yeah.
Yeah.
Yeah, I mean, I suppose ultimately what happens to all the power which goes into HPC system is it all eventually turns to heat. And so if you're designing a new center, what you really need to do is make sure you've got a responsible way of dealing with that. And if you visit one of these places, what you realize is that most of the machinery is actually to do with dealing with how to get rid of this heat. So, for example, the HPC in Finland, in Kajaani, Lumi, is connected up to the district heating system of the city, so they can actually use the waste heat to heat homes. So we need to think more about things like that. I know certainly that the ACF in Edinburgh, they're planning to use groundwater for heating, and maybe some of that will be recycled for sort of cooling, and that will be recycled for heating as well. And on top of that, the other thing we should really be thinking about is how we can write our code to be efficient and actually use the use the hardware correctly, because if you're just using a lot of cycles but not actually making the most of the hardware, which is actually often the case with the modern GPUs, people are not really using it to the full extent, then you're just wasting energy. So it's our responsibility as well.
Carolyn, you?
Yeah, agree with that. Yeah, so for those people who haven't been on a panel, there's a big red button that says "Do not press" next to it, which is just amazing. Yeah, so I totally agree about the efficiency side of things. I think we've heard some really interesting discussion about that already. I think one thing we could do with, say, our PhDs and so on is give them carbon budgets. It's something we're thinking about at Manchester. So that might be one way of improving efficiency. On the other hand, we're probably never going to be in a situation where we're not using all of our capacity pretty much all of the time. This is what we tend to find, right? So the energy usage will still be there, and we've got to think about the life cycle. And we probably want to maximize usage of most of our equipment, our hardware, while it's still viable. So there's the kind of full carbon life cycle thing to think about there. But we do absolutely want to make sure that we're being responsible in the way we use it. So let's use it for research and not for, not have unnecessary cycles in there.
I don't have much to add on this topic. Like, I'm not an AI person, but from discussions within our School of Computer Science, it's more looking at, as academics, we have to work smarter, because we can't work harder. Like, we do not have 100,000 H100 sitting in a data center that we can train our LLM on. So they need to work out how can they do things smarter or come up with new techniques. And I think that's probably going to be the way that we see that we can actually utilize less hardware to do more stuff. Like, I think Samsung has now come out now with another technique for another like recursive model that's nano and can give much better performance with a lot less parameters. So it's needed to do stuff just smarter, really.
Yeah, and being the last panelist to answer, I don't have much to add. Agree with what's been said so far. The side of UCS Advanced Research Computing Centre that I look after is mainly around our training and research collaborations. And so given the embodied emissions in any HPC or particularly AI machine, actually, how do you then use that to achieve the best research outcomes, I think is the critical question, rather than reducing the energy usage per se. And so training the researchers who are working on these systems, how to develop their codes well, what kind of jobs actually work well on different systems, providing mentoring and collaborating with them in order to ensure they're actually making the best use of the systems and producing high quality research outputs is key.
Yeah, so any questions from the audience on this, or any kind of suggestions or comments?
Anyone like to ask a question to the panel? Yes, sir. I should just stand by you. No.
One example about working smarter instead of harder is what the Chinese did with their GPT version, because they did not have access to the latest, greatest NVIDIA GPUs. They just said, okay, we've got this data already out here. We just use that as a training and not just start from scratch. So maybe we should learn here a little bit from them. It's more common.
Yeah.
Anyone? Yes.
Yeah, agreed, always in favor of working smarter.
Happy to take another question.
Yeah, here.
Okay.
Okay, so
Responsible culture could also be around thinking about the impacts of the research we do. So things like dual use. Would be an interesting sort of get your views on that. How do we I guess avoid having bad reuse of our work?
So is the question, how do we avoid dual use?
So the dual use question of we've
Export control, is that what you're talking about?
in that territory, but more generally, if we do AI research on our HPCs and we have these great goals in mind, but then that could have applications in areas we really don't want to contribute.
I feel like I want to turn that round. Is there something you think about in your own work? I mean, so because I agree that it's worth giving thought to these things. It's quite difficult to predict in advance. What we should be doing, how we should approach that. I guess we have the responsible research and innovation framework, don't we, for kind of asking these questions? I don't know whether people think that's fit for purpose or not.
I would assume in part it's contradictory with open research. Like if you're developing something which has a lot of positive applications, which is your research, and it's deemed this is useful common knowledge, you want to follow the open research principles. And it's just simply contradictory that I can put my license on saying you must not use this for military purposes or similar, but there's no guarantee that some international person won't just pull that off GitHub and say, oh, I'm going to actually use it for this and not tell them. So it's just very difficult, and you need to make your personal decision on how you want to sit in that, I think.
I guess it's also the case that rarely do the people who run the systems have the decision over what codes are run on them and what research they use to do. Normally there will be academic governance panels or resource allocation groups or similar processes that will decide how the machine's use is prioritized, what researchers get access for how much. And I think that's the right way around. I don't think as the people running the systems, we should have the final say on that. But we certainly should have input. And that's one thing we do when people come to us with projects that we're looking to shape, is actually from our technology expertise perspective, what are some of the ethical implications that you're doing here? And we get the chance to push back and say, have you actually considered X, Y, Z?
I think it's like more of, again, responsible coding kind of thing. We need to come up with some ground rules. We need to establish some principles in which we say that, okay, you have this specific X amount of available resources. First, you need to come up with responsible code that, it doesn't use excessive cycles. It has to be like optimized. We need to work on the optimization. And then secondly, we need to train people as well, because right now the simple user, he doesn't have much training. He doesn't know how to optimization is one thing. And then again, as I said, we want to use maximum resources just for the small tasks. So again, we need to train the end user that don't come up with the big questions. Just first work on your side, just come up with the optimized version and then run that on the HPC system. So
there's a question. So here, this maybe still there's a question from your side, or you wanted to ask a question?
So about the responsible user, I think that you already answered pretty well. I wanted to come back on the energy consumption and so on, and stress again that yes, we should make sure that we use the energy as well as possible, but it's really also the total cost of ownership, and sometimes there is depreciation included. So using to lower users sometimes is not good, because you are your energy, but in the end you lose your infrastructure depreciated, and you are not extracted all the value from it.
Yeah, I mean, we agree that we need to find a balance. We need to find a trade-off. We cannot reduce the number of operations. We cannot reduce the number of users. We want maximum participation, but we don't want them to use their maximum resources, because they have to know that it has to be in certain limits. It has to be in certain cores. They cannot use all the cores, because we cannot dedicate one complete GPU for one small process which is running on the full capacity. It is consuming energy, but at the end of the time we are only solving one problem. So yes, I agree. We need to find a balance, of course. So.
Yeah, so I have a follow-on questions to some extent on the scale, because now big companies are, for example, Amazon or Azure, they're also offering HPC in cloud. So they could, to some extent, afford to have the optimizations that individual centers may not have the capacity and the resources. So how that's going to have the impact on the cultures within the small HPC environments within the universities, when big companies may offer the same type of resource in terms of energy consumption, for example, at a fraction of the cost, as compared to a university who may not be able to have the resources in terms of scale, a number of people and the number of servers. So how that would have impact on the culture itself that we are trying to embed in the universities. So maybe on your side, Ezra?
Yeah, interesting question. Somewhere we're getting feedback. Ben in the audience probably better to answer from an art perspective because he looks after the systems. I think one of the things that we've particularly focused around is open source software stacks for running the systems and then contributing that knowledge back to the wider university community in different ways. So yes, each individual university might not have a very large team, but collectively we have a wide diversity of systems, of users, of skills within the teams. And so by exchanging knowledge together, we can actually do a lot of experimentation and a lot of building on the either successful or failed experiments that others have tried to improve how we operate systems.
So, I mean, sorry.
My limited understanding of this from Sheffield is where we do HPC in cloud, it's very much limited to trusted research environments, things that they cannot run on local HPC. I would assume it's largely a cost driver. So they're very worried if you give an academic access to unlimited GPUs in the cloud, they're probably going to use a lot more than if it's more limited and they've got the pressure of, oh, other people are trying to use this, I don't want to use too much of it. So unless that cost can be brought down to something where the university knows they're not going to overspend, it's probably for at least the generic HPC stuff where they don't need specialist hardware, it's very difficult, I would imagine, to migrate stuff. But I don't know the costs, so I'm not involved in those decisions.
Yeah, I mean, so I think on this issue, I don't know if it's so much to do with energy consumption, because as I understand it, a lot of cloud environments are quite energy efficient. It is absolutely as you're saying, the issue is around the cost, probably. So I guess that constrains the energy consumption, hopefully. But I don't. That's kind of my perspective. Money will sort it out.
My perspective would be that yeah, it certainly could work well for commoditized kind of applications. So things which run simply on a single node, but for many research codes that run with MPI across multiple nodes and require parallel file systems, it's really much more convenient to use HPC centers rather than cloud provision.
To answer your first question, that was industry only works on the justified or set patterns. They already have set rules. That's why they're expensive. They have their tools, they have their algorithms, which are defined, which are tested, tried. That's why the industry solution is expensive. In academia, we do have some freedom, so we can come up with like more scientific curiosity. We can dig out more software or hardware ways to find like more to go through the solution base that, okay, if industry has the solution, how we can come up with more optimized or which is less cost as well, which is less expensive, and it gives us more performance. So academia gave us that thing. So I think we can like do more research. We can come up with more scientific algorithms to solve that problem.
Yes. So any questions?
Yeah, so I asked Louisa, who presented yesterday, she's online, and she asks or makes a statement saying part of finding the balance is in training end users of the technology, because in most cases they believe high performance is part of the technology acceptance model principles, leading to over provisioning and more power consumption.
Mm-hmm.
Is there a response to that? Agreement?
Yeah, I think users will often ask for more than they think they need to be on the safe side to make sure their job will complete.
Yeah. Yes.
Yeah. I am not connected with that. I'm not sure that cloud providers are more cost effective, at least compared not competitive, they are less cost effective because they need to over provision to adapt to spikes of usage, and they need to make profit. So that's two things that makes the difference. Not for maybe for small things they can be, because then you need to have paid people to maintain everything and so on. But it's not obvious that it's less expensive. At least I think it's more expensive.
Yeah, agreed.
Agree, yeah.
Warren has a question.
Yeah.
So, building a responsible HPC-AI culture, cultural change is difficult in general. So, if you had to suggest a top priority or a potential quick win, and they may not be the same things, what would we suggest? What are you either most concerned about that we really do need to fix, or something that with a relatively minor change we could make a big difference in any aspect of people, practices, performance?
So Jonathan,
So I'll steal a bit from my talk that comes up next. That one of the areas we're particularly looking at is developing leaders within this space in sort of the academic adjacent sector within the UK. Because if you get the people who are leading locally in their area, who have an interest in this, are passionate about it and driving it forwards, for a relatively small investment, you can have much greater impact across the sector. I'm sure there are other approaches as well, but I'll let the other panelists answer while I think a bit.
Like, as you'll have seen from my talk, I think the biggest wins are where we can do the introductory hot path basic profiling, where we can potentially find things which are 5-10 times faster in a short period of time. The challenge is kind of teaching these skills to new researchers, because when they're starting out on their PhD, they're being thrust into all this training, all this introductory Python, Git, all this training. But that's not the right time to teach them the right profiling. Until they're comfortable with actually Python itself or C, whatever, if you thrust them into profiling, it's not going to be useful at that time. We see this again with Git training. If we teach people like week 1 of their PhD Git, they're probably not writing their code until 6 months into their PhD. And then they come and ask us for help because they did the training and they've since forgotten it. It's very difficult to catch researchers at the right time. And that's what we need to try and solve. Like at Sheffield, we have just difficulty marketing our RSE team. We put out a survey and go, have you heard of us? Have you heard of our training? And you've got 30% of people saying, I didn't know you did this training. It's just difficult. We need to get marketing people, I think, on board.
I mean, I still think it's really interesting because I've worked at the SSI for a long time. So obviously talked about research software engineering this morning. I still think it's really difficult getting that message across. And I had some really interesting conversations at the break as well, because of course I talked about RSE because that's why we've done this study. But of course, there are lots of other professional roles, particularly here, that will sit around that. So, you know, looking at hardware and platforms and infrastructure, and have a different role in kind of supporting research from that perspective. So I think recognizing those roles and sort of moving towards professionalization is a really helpful thing. I think that's happened in some areas and some institutions, perhaps less so in others. But I absolutely agree with what you're saying about, I still think we're not really recognizing the importance of like really good practice, like good software practice, good engineering practice in research. Like, I think people in this room recognize that, but I think we all have lots of colleagues who maybe don't get it. And my worry, and the reason why I think this is a top priority for me, is because you say, oh, well, we're moving in the right direction. I'm really worried that we're not. I think we're going to be miles away from it potentially in the future because of auto-generated code. I don't know what the implications of that are going to be. Some may be positive, a lot may be really negative. So I think it's just something we need to keep an eye out for. So, you know, maintaining those values.
Well, in terms of sort of responsible AI and thinking about how the future is going to be, I think what I'd like to see is more moderation, because I often feel that there's some people who say, oh, you know, they're very enthusiastic, AI can solve every problem. And then there are other people who are very skeptical and say, well, AI can't solve my problem at all. And there should be more room for people, there's more opportunities for people to talk to each other and not to get polarized to one end or the other and say you can't do it with AI or you can only do it with AI. So I think that's a space I'd like to see develop more, where people can actually have more sort of reasonable conversations about it.
So my worry right now is that we are using AI and we are not using our own minds. Sorry to say. The thing is, we are asking AI to generate a code. It's doing coding for us. And if we want to do the optimization, if we want to do the responsible coding, we will ask AI to do the responsible coding for us, write a responsible code for us or optimized code for us. So at the end of the day, we are asking AI to even do the work, which are supposedly our as a human job to do that thing. So because at the end of the day, we are trying to optimize AI by using AI. So it's like, it's like the conundrum right now. So we need to come up with some sort of practices, or as Mark said, that we need to look into the culture. We need to come up with ground rules. Yes, this is acceptable from AI. This is not acceptable. So, yeah, that's it.
I don't mean to be obtuse, but I've heard code optimization for the past 20 years. And no one has really done that. And so now we're asking AI to do it. And I don't know what the reason is. Maybe we're all too busy, going on to the next thing. And that's why all these legacy scientific computing codes are just in shambles the way they are today. So when are we going to actually do that? Right. So if we can't personally do that, and the easiest way is AI, what's the other way? Are we going to actually dedicate personnel to really get our codes in a more sustainable model? Sure.
Even though my voice is completely gone. That really took me on. What do you mean by we didn't do anything for 20 years in code optimization? I mean, yeah.
If it happened, we would be talking.
Because we always want to do more, go faster. There is no end. It's
a process.
Yeah, it's a process. And if you look at our community, we have answered such, the one I have involved in my last previous job in this, weather and climate, just see how far it has come across in terms of weather modeling and prediction, how accurate you could do it. So how could you even say that we haven't done it, we need AI? What I think the discussion here is, I don't know, for me, HPC-AI is the same thing. It's AI is an application agents, right? Different, but is the, agentic part we are talking here. So I'm sorry, I because it's really taken off from that perspective. Yeah, we should use tools. We should not be afraid of AI. So yeah, if I can get some help to analyze my code or something, I would use it. I think that is the part where I thought maybe you were saying, and I'm sorry not to put words in your mouth. I think the part which is still escaping us is this panacea of auto-optimizing compiler, like like a tool that could do all. I think with the AI type of tooling and analysis, we will make a huge progress in the compiler, code generation, code analysis capability that didn't exist before. So in my mind, there are two different things. Optimization through algorithms, through other things have been done. But there is a large part, and I think that professionalization or generalization or standardization, AI will help because there will be more as human beings. So I'm very positive about the AI, but we need to be always very academic about how do you say the professional or scientific integrity. This doesn't matter in the discussion, and we should always keep that in mind. So sorry to take that contrary, but you can answer this question.
It wouldn't be an HPC-AI Advisory Council conference if I hadn't pissed off Sadaf. So thank you. I've at least completed that goal for this conference. But no, I say it only in a contrarian way that this is something that I continue to hear. So without further diving into the details, because I'm not a software engineer and I'm not doing any of the coding, from my worldview, I don't see it happening.
So to some extent, AI is in a tool, and if we could help us to improve our code, why not? But yeah. So question.
Well, I guess following on from that, some codes are highly optimized. I'm sure the stuff that Chris works on, for instance, runs very efficiently, but a lot of the scientific software is researcher written, single or few use codes. And while some researchers know how to optimize, a lot of them don't. And when you look at the code, you go, well, this is blatantly doing an awful lot of stupid things and could run 1,000 times faster with very little effort, but they just don't know. And that's possibly where some of the AI-assisted coding could actually help if those tools understand the simple optimizations that can make a big difference in most cases and actually tell the researchers to produce things that don't do all of the normal stupid stuff that you often see.
Yeah, I mean, I don't think we should just throw away AI and say it can't be useful for code review and helping us to write better code. But on the other hand, when new hardware comes along or new ideas, it is really important to have the domain knowledge of not just programming, but actually the scientific area. Maybe some completely different technique, which will work much better on new hardware, which is equivalent, but will use a totally different method, let's say. And I don't think AI would see through that and understand that that's something that is possible. So developing software is a process. It's continuous, and you've got to just be always thinking about what's the next best thing that we can do.
Yes.
So I would like to go back to the first it's about people, and Jane mentioned, and I think it came up earlier, and maybe you mentioned Caroline. I mean, for me, I have had great mentors throughout my career, and my field. So you talk about RSE having not proportional representation in HPC. If you go to storage or system architecture, it's kind of a even a different story. So with this changing landscape, where our leadership or people who are in the position of leadership who are confused or in some cases are having some identity crisis, do you think mentorship can still play a role in going where we are going and how we could do? Because to me, this is great. I can say this, I would not have been here if I had never had a great mentor all over the world for different parts of my career. And and the best thing they kind of instill in you is the excitement and joy about doing something more than how you do it.
So just to respond to this one, I think what you raised is really, really important. I think everyone in this room has benefited from mentorship, and not just mentorship, but sponsorship. So mentorship in the sense of, oh, you can talk to me about your problems if you want, or I'm going to say encouraging words, right? It's like, I know this person. If you want this job, here's how you apply for it. This is what you put on your CV. This is what you write in the letter, right? Everyone in this room presumably will have benefited from that at some point. And that's why you're in this room and maybe some other people aren't. Not the only reason, but you know what I mean, right? And so I think we need to get away from, I totally agree with you. So I've had really strong mentorship, sponsorship as well, which has helped me in my career. But I think what we need to recognize is that everyone benefits from that. And we need to make sure that we are kind of supporting everyone in the same way. So basically the whole sort of social identity thing that I was talking about earlier, that some people would have heard about, we're very comfortable with familiarity. And this is true for everyone, right? This is just how we are as humans. We become comfortable with familiarity, and we know where we are with people. And one of the really interesting things about diversity research is that you find in teams, people would have heard that you have a team that has diverse ideas and backgrounds who tend to do better, and this is true. But also it can be much harder, okay? There are times when diversity in teams can be challenging for everyone because you get more disagreement and stuff like that. And there are other studies that show that those teams can sometimes perform worse, right? So it's tricky. But I think going to your point, what we really need to do is make sure that we are thinking about everyone, we're thinking about those opportunities. So what I try to do myself is think, oh, this person would be great for this job. But why aren't I thinking about this person? And what about this person? And you just challenge yourself to kind of think outside of where you normally would.
Of course, the change will start from the top. Being a good mentor can create hundreds of sub-mentors, then they will teach others and others. And that's how I think the change will affect at the end. So yeah, I think this is what we need right now. So.
I got another question online. We have a couple minutes, so we can do this quickly. Do you think coding with low abstraction programming languages and training users to do so, as in the past years, can make any difference in energy consumption with modern hardware?
That should be me, I think. Again, the thing is, again, that there comes a part of code optimization, how well the code is written, even if it's the low level language, if it's the C or Pascal or whatever. So if it's like well written, if it's not taking much resources, then yes, we can work on that. But again, we can come up with the counter arguments of getting better techniques to reduce the consumption and come up with like the optimization, to overcome the optimization challenges we can have in this case. So in short, yes. But again, it can come with different conditions. So, yeah.
Yeah, I think you need some people who understand the low-level languages and can do that really well. But actually, for the majority of people, that's probably not the right way to go. A lot of the time, actually, if you write some code in Python, making good use of NumPy and SciPyStack and so on, it's going to be a lot faster than if you try and hand roll the same sort of algorithms yourself in C++ and Fortran, because other people have done a lot of the hard work for you. So making use of what's already there, making use of appropriate abstraction levels for the problem you're trying to solve is probably a better bet in the majority of cases.
Yeah, I'd also just say using the latest tools is important. I mean, what we've noticed is, for example, the newer compilers are just so much better at seeing optimizations and making your code run faster than even ones just from 5 years ago. So yeah, very important.
I'll defer to the experts.
I suppose the one thing is there are a lot of researchers who have code that would be suitable to port to GPU, but they do not have the skills to do it. And likewise, it can take months for someone who knows CUDA to port a substantial project. Like that second case study from my talk earlier, I did port that quickly to CUDA in the space of about 2 months. Like, it's not in a polished way. It was like, can I fit these things like a plug in the project? And they're now trying to maintain that code. So like there's a lot of challenges where people could benefit from low-level languages, CUDA, or more advanced hardware, but they just do not have the skills to develop and maintain it, and it's difficult for them to find the time to pick up those skills.
And this is to some extent a common problem within the universities, because whenever a student is trying to optimize code, so they to some extent grab the whole resource there, and then other people are in the queue and they want to run their code interactively because they're not sure whether it's working or not. And as a result, HPC admins are complaining that why your school is consuming so many resources, while actual wall clock time is to some extent only a fraction of that. So how can we deal with that particular scenario where we should encourage use, but then also we should to some extent have a culture where other people should not be in the queue as well, actually?
HPC is not for code development. Like, it's just difficult. Like, you can't really do batch jobs where you're trying to do back and forth. And then certain resources such as GPUs, it's very difficult to get interactive jobs, especially if there's a machine learning conference coming up in 2 months' time and they're submitting 10 papers from the speech and hearing research.
But then however to convince the PhD students that HPC is not for code development and only for...
But I mean, typically, at least at Sheffield, students who require GPUs will have them in their office machines. We have managed desktops with GPUs. We don't typically encourage students to try and use HPC for code development. Some will because they want to work remote, they don't want to sit on campus. But generally, we have provision for doing GPU stuff on a machine you can sit at and use yourself.
So then there should be to some smaller facilities within their own schools for code development, and because schools cannot afford a GPU for every student.
I mean, yeah, this is why they're in just the general university computing labs. Like, it's part of why computer science is more financially sustainable at Sheffield. The computer labs are used by students across the university, so they're not funded by computer science. Like, the engineering students need GPUs for their modeling software, for their simulation software. So these are just widely available, and you just make them available to the students who need them.
Any last comments from the panel before we conclude? No. Thank you very much for your insightful discussions. So
Thank you.
thank you for the panel.
Thank you, everyone.